Hello and welcome to Connect and Collaborate. I'm Alex Hopkins, your on-air producer, and I am excited for today's show because I have somebody special in here. His name is Steve Caruthers, and he is with Airbat Helicopter. And as most people know, I have a really huge heart for aviation. It has been a big part of my life. But this is a really, really cool aviator we have, an aviation invention, if you will. But I want to get into that momentarily. In the meantime, I also have Keenan Brugh in-house with me. He is with ICOSA Media.
Yeah.
How are you doing, Keenan?
Doing well. Thanks for having me. I'm excited to get into this show. I love new technology and what's on the horizon and how we can bring a future that could be into reality here today. So I'm excited to be here with you and learn today.
Great.
Yeah.
Appreciate it.
So, Stephen, let's talk about your background, your aviation background, and then we'll hint a little bit about what you're actually here for, but we'll get into it specifically a little later in the segment.
Okay.
But we'll start here with you.
Well, I think I should probably say I don't have a very extensive background in aviation. I kind of stumbled into this thing, as it were, which to me is kind of an interesting part of the story. But I was raised on a ranch and wheat farm in South Dakota. And one of the tools that a lot of people use, including my brother and I, is what we call Super Cub, or small airplanes where they can land in places. And we just thought that was the biggest kick. In fact, my first airplane ride, a lot of people are not going to believe this, but this happened to me and I got hooked when I was 9 years old.
Wow.
Of course, people raised on farms and ranches grow up very fast and go to work and so forth. But I got a job when I was 9 years old as a flag boy for an aerial spray service, and they were using two Super Cubs. And of course, I could drive and everything else. And part of my job was to spot the flag boys and drive around this Jeep. Well, one spring, that spring, I'm not going to say when this was, but but anyway, it had been raining and it was muddy and we couldn't spot the flag boys with a vehicle, so we had to spot with the airplane. Well, picture a Super Cub. It's a tandem. In other words, the passenger sits behind the pilot. Well, they took out the back seat of this Super Cub and they put in the nurse tank that carries the spray. And so there's no place to sit other than the door is split in half, and the top raises up and hooks underneath the high wing. The bottom one drops down, and it leaves a little ledge. It's maybe that wide, with a hinge. So if you might picture, here I am, 9 years old. My feet are inside, and I'm holding onto the seat, and my butt's hanging out the side in the wind and looking down. I mean, it was the most fascinating thing as a 9-year-old. I mean, I was thrilled. It did not scare me in the least. So anyway, that was the one thing. From then on, I'm hooked. And like I said, we had a Super Cub. Well, one of our neighbors, a guy he was quite a bit older than me, but anyway, he had a habit. He was a pretty big farmer. He's farming maybe 30,000 acres.
Oh.
Big farm.
Yeah.
And we were farming quite that much, but close. But anyway, he had a habit of he would fly over his crew. They'd be on the ground. And he would cut the throttle and shout down instructions of where to move to the next field or whatever. And he had his son-in-law, brand new son-in-law. He and his daughter had just gotten married, in the back seat, and it stalled. And he was only about 100 foot in the air. And any type of an aircraft, when it stalls at close to the ground, it just does this number. And it did, and it killed him. And his son-in-law killed both of them. Whoa. But anyway, and that was in the early 70s. Well, anyway, I left the farm and ranch in the late 60s and went in the commercial cattle feeding business. And I was managing a quite large 28,000 head commercial feed yard in Nebraska at this point. And I'm buying hay from a guy that lives quite a ways, maybe 100 miles further west. ground alfalfa. And he stopped in to see me occasionally, and he stops in one day, and he's all excited. He'd driven through Minden, Nebraska. And he's all excited. He'd seen this little helicopter flying, and he turned around and stopped and met the guy that had built this thing and put it together. And it was a tail rotorless, what we called then an air jet rotor helicopter. And he was flying it around, and he demonstrated it for him, and he showed up at the feed yard there where I was, and he's all excited and telling me about it. Well, that next weekend, I mean, that first opportunity I had, I called this guy, gave me his phone number, name, and I went and saw him, and he demonstrated the helicopter for me. And this was in March 1978. And anyway, long story short, I became very, very excited about this helicopter because it has no tail rotor. And I'll explain to you how this works here real quickly so so people understand what it is we're talking about. But we call it an air pressure jet, or APJ for short, helicopter. With a conventional helicopter, the main rotor is driven by the engine, whatever the power source is, through a system of gears and gear reduction. It turns the main shaft, the rotor being attached to that turns the main rotor. That puts a counter-rotating torque on the fuselage of the helicopter. So to counteract that, so that only the rotor turns and not the fuselage, so you can fly it, it has an anti-torque device. The most common one, it's not the only one, but the most common one is a tail rotor that thrusts to the side to counteract that torque. And you control the pitch of the blades on the tail rotor with your feet, so you can stabilize the fuselage. Well, if you might visualize, and they're very, very difficult to fly, to learn to fly. I mean, there are guys who fly them and it makes it look like it's a piece of cake. Trust me, it is not. It takes a lot of skill, a lot of practice, a lot of learning to feel what it's doing by the seat of your pants to the seat, that sort of a thing. But anyway, the vectors, the main rotor is up here at this level, and that plane of that vector is up here. The tail rotor, by necessity, is at a lower level. This makes it kind of want to waddle in this manner rather than just this manner as well. Just part or more of the difficulty in flying a conventional helicopter. That fact, plus all of the gears, the number of gears and transmissions and drivetrains to the tail rotor, and then you've got a right angle drive, and then you've got to have the controls to control the pitch of it and everything else. It makes for a lot of moving parts and high maintenance costs, a lot of time spent in maintaining that helicopter, along with being very, very difficult to fly. And we believe that those factors, all in toto, has greatly limited the demand for helicopters. Well, anyway, what attracted to me when I went and saw this guy flying this little helicopter, I've got somewhat of an engineering background and being a farm kid as well. I just understand, I know exactly instantly how things work. That's just part of who I am.
Well, that's a trait I'm jealous of.
Well, in this case, it was very handy. But anyway, this helicopter, conversely, the main rotor is driven. All the engine does, and it's hooked direct to a centrifugal air compressor. It's an example of one that most people have seen is the turbocharger on a diesel truck or diesel engine, or a lot of cars today have turbos. They call them just turbos for short. That is a centrifugal air compressor. The discharge in, the part that blows the air, that's a centrifugal air compressor. This is the same thing, only it's bigger, but it has that scroll to it. Well, anyway, we use an engine, generally speaking, a gas turbine, although we're considering looking at electric motor using batteries as the power source, but batteries are not here yet. But anyway, a gas turbine engine direct driving a centrifugal air compressor at about 61,000 RPM. Well, anyway, that blows an awful lot of air, and we duct that air through a non-rotating mast,
Okay.
up to the rotor system, or the rotor head, and it's ducted down inside hollow rotor blades. It travels out those rotor blades to the extreme outboard tip, where it exits through rearward-facing nozzles. They're 1 3/8 in diameter, about that big. That air pressure jet turns the rotor, like a rotary lawn sprinkler, or is a familiar example. But that turns the rotor. So it's a freewheeling hub. There is no torque.
Because the force is coming from the tips of the
Correct.
blades rather than from a center high torque sort of spinning rotation. Okay.
Exactly, Keenan. Yes. So that means, number one, there is no torque, so no need for a tail rotor or any other kind of an anti-torque device. The benefits are, number one, it makes it much, much, much easier to fly. It makes it so much easier to fly, it's just almost like it's not even a helicopter. In fact, well, I taught myself how to fly this thing, and I think for a lot of people who are a novice pilot, they're not trained to fly fixed wing or anything, would pick up flying this helicopter more quickly and more easily than they would be a fixed wing airplane, because you can just pick it up, you can hover with it, you can play with it till you get a feel of how it responds, how much you have to move the controls to get it to do what you want to do. But then you can go in translation and climb on out. But it makes it easier to fly, much, much easier to learn to fly. But it also makes it safer. I mean, just from the fact that something is easier to do than something else, in and of itself makes it safer. But it's safer because it's easier to fly. There's fewer moving parts. There's also no dead man's curve. Now, let me explain what I mean by that.
Yeah, please.
Okay. Most helicopters, in an elevation within 100 feet of the ground, if they're hovering, now you see helicopters do this occasionally, but trust me, that is not a safe thing to do. They're doing that out of necessity. But if they don't have very much forward speed within this, say, the first 100 feet of the ground, and the engine quits at that point, they're going to have a hard landing at best. Not necessarily it's going to be fatal, but it's definitely going to be a very, very hard landing. And part of that is because the main rotor is coupled to the drivetrain. It's coupled, direct coupled. It has to be by the pilot uncoupled. He has to do something. He has to lower his collective to uncouple that. Plus, there's very little range or operating RPM range of the main rotor. That's not true with ours. Since there's no direct coupling, we can overspeed the rotor. In fact, most of the time we fly with a higher RPM than what would be, shall we say, necessary for normal flight activity. So we fly with a little higher RPM. If you would think of this as a big gyro up there, this rotor, it's 36 feet in diameter. They're fiberglass, beautiful set of rotor blades. But there's a lot of spinning inertia in that rotor. Mm-hmm. So that if something happens and you're hovering, let's say at 100 foot in the ground, you can dip the nose down and land this helicopter just easy as pie. You can also overspeed the rotor sitting on the ground, and it'll jump 100 feet in the air so quick. Yeah. I mean, it's really fun to fly because it's not rigid in what your operating limitations are, or as rigid in the operating limitations than what they are, as they are in a conventional helicopter. So it makes it safer, easier to fly. Also, there's about 85% fewer moving parts
Wow.
than there is in a conventional helicopter. That means a couple things. Number one, maintenance is a lot easier, a lot less time consuming, a lot less costly. It can be performed more by, I hate to use this word, but I'll use it so people get the picture, by novice people. But someone who's trained but not necessarily an expert.
Right.
Okay.
There's nothing wrong with the term novice. I hold that title very well.
I hear you, Alex.
Yeah, but I like that. I like that it's something new pilots can learn on, which
Yes.
is fascinating.
Yes.
And the 85% fewer moving parts that you just mentioned is mind-boggling to me because
Right.
overall it's going to be less cost. It's going to be easier to maintain. I
Less
love
points
that.
of failure, too.
Exactly, which is amazing.
Exactly. All the moving parts are most in the power unit, and when we're using a a gas turbine, the turbine we use is called the Titan series gas turbine, but it puts out 250 horsepower and it weighs 90 pounds. I mean,
Wow.
I could, you and I could carry it in here. I could by myself if I had to, but I mean, 90 pounds.
Wow.
And it's direct drive coupled right to the air compressor. There is no transmission at all. And then there's the flexible coupling, but ducted right up into the rotor system. So the only moving parts are internal in the power unit, which is a one shaft. There is no transmission. There's a compressor stage and the exhaust stage, and then the centrifugal air compressor and its carriage bearings, but that's it. In the rotor head, there's a seal that rotates from rotating to still, and then the swash plate and the teeter bearing, those sorts of things that would be in a normal helicopter. But other than that, there are no moving parts. And I use the word 85%. I really don't know what the exact number. I actually think it's more like 95, but I'm happy with saying 85.
Even 50 would be shocking.
50 would be shocking, right.
Yeah.
So you described a little bit of the problem with conventional helicopters and how this new technology or an existing technology brought into the future can provide some solutions. To me, the analogy seems a little bit kind of like a conventional vehicle automobile with a Tesla, where there's a lot fewer moving parts. You don't need the transmission. You can potentially move towards a battery power. How would you describe what Airbat is? So describe the company and the project of Airbat.
Excellent. Well, first of all, I'll start with the name. Airbat. That's an interesting name. It's spelled A-I-R-B-A-T, where the B-A-T stands for battery. And our dream, battery technology is not here yet for a couple of reasons. One being safety, the other one being weight, where it's suitable for aviation. I mean, there's some companies, and we're in touch with a whole bunch of them, that are getting close. To say it's 1 year, 5 years, I have no idea. But I think at some point in the future, and hence that's why we named it Airbat, because we really believe it will eventually be here. And we're in touch with a number of people that are in groups, organizations, companies that are in the process of developing batteries suitable for aviation. We want to be in on the cutting edge of that. In fact, one of our major overriding goals is to develop a completely green, and I'll explain how we're going to do that here in a minute, but a completely green helicopter. It could be a 2-place, 4-place, 6-place, whatever, but we can make it completely green by having batteries in a battery pack, an electric motor that's now driving the centrifugal air compressor. That's the only difference. We're going to replace the gas turbine with the electric motor. So with the battery packs, it may end up actually weighing a little bit more, but not much more than the gas turbine. But the benefits take it to a whole nother level. And by having recharge stations, say like along I-25, to give a simple example, like if you're commuting from Colorado Springs, which is where I live, to Denver, and you forgot to charge your batteries, you could stop and charge. But those battery charge stations would have battery packs that would be interchangeable with the ones that is in your helicopter. And those recharge stations could be powered by solar and wind. We're in conversation with another group that has the technology already available for both solar and wind in a small, compact recharging station. And we could make this helicopter, shall we say, 100% green, or where we could be. You mentioned Tesla. Maybe we could be the Tesla of the air,
Yeah.
so to speak. And that's our overarching goal over all of this, is to be on the forefront and involved in the technology as it becomes available, to incorporate that into our little helicopter for personal transportation. We really believe the major market, untapped major market for this helicopter, actually it's twofold, but the first one that we can fulfill with the gas turbine. We can even do better with the battery, but with the gas turbine is what I call just general aviation. In other words, it's someone wanting to commute to work, to fly to see the grandkids, or whatever the case might be. Maybe it's a businessman and he has more than one location, and he can fly from one location to the next. We also have emerging technology that I'm not going to discuss today. It's proprietary, that will allow us to not only have the battery powered, but it could be gas turbine or battery, but we will have a helicopter, 2-place, 4-place, and a 6-place helicopter that we're going to certify that will be 180 plus mile an hour helicopter. It's just almost unheard of. But with this technology of the APJ, or the freewheeling hub rotor type that we have, it allows us to get creative in how we propel this aircraft through the air. And that's all I'm going to say about it today. But we are really, really excited about those two technologies coming down the road.
So 180 miles per hour sounds really fast to me as someone used to driving a car. How does that compare to a helicopter of the similar size and class?
Right. Good question, Keenan. Typical helicopter in this price range, where this one's going to be 120.
Okay.
120 to 130 in that range, top speed.
Wow. So it's about 50% faster.
Up to that, yeah.
Wow.
Yeah.
I am so absolutely fascinated by this. And the Going Green, I think it's a wonderful initiative, and we're very close on that. I love that.
Yep. Yep.
Gosh, there's so much that we can get into. We are limited on time, so in this last little bit, what is your website? Where can I find more information before we come back?
Yes, our website's very simple, and my contact information is all there. It's Airbat, AIRBAT, helicopter.com. Airbathelicopter.com.
Awesome. And I know that when we come back in our next segment, we are going to ask our audience to find out more information on their own and see if they want to get involved with this, because we have some investment opportunities on this ground floor that we can get people taking off with you, right?
Yes.
Yeah. All right. Well, stay with us here on Connect and Collaborate for this fascinating conversation. We'll be right back. Be sure to like and subscribe our YouTube page while you're here. Check out cobrt.com/radio-podcast for this show and more. And actually go ahead and check out Airbat on our radio page. We'll have pictures of the rotors, and we will also hook up that website there for you. So stay with us. We'll be right back. Welcome back to Connect and Collaborate. Once again, I'm Alex Hopkins, your on-air producer, having a fascinating conversation today. Again, I have Keenan Brugh in house with me. He is with ICOSA Media, and we also have Stephen Caruthers, Steve, as we've been calling you.
Yeah, Steve's great.
Yes, yeah, wonderful. He is with Airbat Helicopter, and again, we are talking about this air pressure jet. It's a freewheeling hub. It's just an amazing foray into this new adventure of aviation. And so we talked a lot in the last segment about where we would like to go with this, right? As far as being 100% green.
Yeah.
And that's through battery packs that you can have at hubs and different locations that will be powered by solar and wind. But we need some technology to catch up with us before we can get those
Correct.
batteries. But that's not halting any production, right?
No.
Yeah.
No,
So
not at all.
Let's talk about that.
Okay.
Yeah.
Yeah, initially we will be producing this as a gas turbine-powered helicopter. The gas turbine, though, will be driving a centrifugal air compressor, not direct driving the main rotors in a conventional, when we've talked about that. But eventually, we hope to, if battery technology catches up, and I really, really believe it will. We're in touch with 4 or 5 different companies and groups that are in varying stages, and they've got different visions, it seems like. So, and I have really no idea. I mean, I'm not a battery guy. Just where this is going to end up, I just hope that it ends up where it's safe enough and light enough for it to be involved in aviation. Because I think that if that ever becomes the case, and again, I believe it will, that solves a lot of problems. For example, not only in that we could make this helicopter completely 100% green, it opens up all kinds of opportunities for what's called remotely piloted vehicles, or RPVs, in that for use in moving passengers from one location to another, maybe building top to building top in major metropolitan areas, those sorts of things. A lot of the there's some companies involved in this and some big names, but the designs that I see being put forth, I don't believe when it comes to simplicity, when it comes to safety, fail-safe type operation, there is anything that I have seen on the horizon that holds a candle to this helicopter, being that it's single rotor, it's not a quadricopter, there's fewer moving parts, it's more fail-safe, it's easier to control remotely, although about any vehicle can be remotely piloted anymore with computer technology, so I don't see that as necessarily an advantage, that part. But the fact that it's easier, fewer moving parts, one rotor, not multi-rotors, it just makes things a lot simpler and easier for that type of an operation. So I see some of those things down the road as we get into this. As I mentioned a few moments ago in the last segment, we are going to start producing this as a kit under the FAR Part 21. But by doing that, it allows us to get into production much quicker. Our prototype is ready to fly. We need to do a few things to get a new power unit mounted on it, and we're not quite ready to fly yet, but I think we'll have this thing flying within 3 or 4 months, something of that nature, our prototype.
Yeah.
Now, that's not the production model. We want to do some engineering, and we want to design work on making it, shall we say, pretty, so to speak. But other than that, we're ready to go and start producing this as a kit. And we can do that by the end of the first year and get it into production as a kit. In the meantime, we're going to be working on certifying a 2-place and a 4-place, eventually a 6. But it's going to be a process, a progression. But we will start off in certifying this aircraft as we move into this. Not only moving to battery and electric power. So we've just stirred up a lot of interest from people when we talk about our vision and what we see in the future. And we really believe, and we've got a lot of engineers that we've talked to and are familiar with what we're doing and familiar with some other stuff that's out there. This really holds a lot of advantages. going down the road. So.
One advantage you were mentioning earlier of the moving people around in a city, so almost like an Uber or a Lyft, and I have seen those companies do a couple maybe more marketing examples of them using conventional helicopters.
Correct.
But that's very expensive with all the parts and the maintenance and the few people who are able to fly those. They probably cost a lot more money. And so that's been in Dubai, as kind of like an example that Uber could get there. But I could see it being much more feasible with this sort of technology where it is easier to fly, easy to produce, less moving parts. And I'm really excited about your overall vision with the electric and the battery capabilities when they catch up, though it's super cool that you can already get started with the new air propulsion technology.
APJ. I'm sorry.
The APJ, even without that part yet. So you have that capability going, and that's what's in your prototype coming up here?
Yes. Absolutely. Well, all of our helicopters will utilize the APJ, or the air pressure jet, air jet rotor technology, whether it's the first ones, the kits that we're going to be producing, they're all going to be incorporating the APJ technology as the basic part of what makes this helicopter have all the benefits that we were talking about. Without that, it doesn't have any of those benefits. So all of our helicopters will incorporate that technology.
That is wonderful. So we've mentioned that this could be great for novice pilots, right?
Yes.
So what is your market here? Who do you think would benefit best from these? Yeah.
Well, when you understand a little bit more, one of the big advantages of this helicopter I have not mentioned, I'll mention it now because it plays into one of the markets, a big market that we see for it, and that is that the air flowing down inside these rotor blades throughout the whole system through the heat of compression is about 400 degrees Fahrenheit, quite warm. So the first of all, one of the big benefits is these rotor blades will not ice. They will not. They're physically impossible because the blades are going to be very, very warm. So the blades will not ice. In fact, we've got one of the airlines up in Alaska is very, very excited about this helicopter because, well, there aren't that many roads. First of all, there's a lot of communities that are very, very remote in Alaska. For about 7-8 months of the year, they've got a lot of cold, snow, frost, et cetera, et cetera, et cetera. This helicopter, being that it's easier to fly, it will land in a small area. You don't have to have a runway. It's easy to fly. It's easy to maintain by novice people, again, using that word. We can see it being one of the markets being these very, very remote villages up in Alaska or Canada or any, Norway, on and on and on. These more remote areas, Russia, etc., of the northern climates.
And you're not spending any money on de-icing fluid, that saves you a ton of money, so you can essentially have an airport for these.
Or de-icing equipment.
Yes, exactly.
Anything like that.
That's amazing.
Right.
Yeah.
And we've also had some conversations with FAA and wanting a different license. We don't want one to have a, shall we say, a helicopter license to fly this helicopter because it flies different, it's much easier to fly, all those sorts of things, all those advantages we've discussed. So, and they're in agreement. They really believe that this should be a different license.
You got the FAA to agree with you on that?
No, well, it's not in writing. I don't have it in writing or anything like that. But I don't need it at this point.
Right.
But we've got in fact, it's in the regulation. There are regulations that support this that will allow us to get a different license that people can learn to. And then they wouldn't then be able to fly a conventional helicopter.
Right.
But our customers are not going to want to fly a conventional helicopter anyway. So it's going to be more akin to a fixed wing license, and get this so that one can get to the point where they can carry a passenger, other than an instructor pilot.
Yes.
That is an exciting market. I had not considered just how many bush planes are currently flying infrequent shipments of lifeline supplies or mail, let alone things like an Amazon distribution. They're just really remote out there in Alaska in so many places.
Right.
And this could bring them mail, medicine, anything, really.
Correct.
Wow.
Correct. And another big market that I see, and granted, part of it's because of my background. I was raised on a farm and ranch in South Dakota. I mean, there are big farms and ranches in South Dakota, North Dakota, Montana, Wyoming, Nebraska, on and on and on. Is farmers and ranchers. It's much safer for a occasional pilot to fly this than, I believe, than even a fixed-wing airplane, much less a helicopter or conventional helicopter as we know them today. Someone who flies maybe once a month or something, or occasional pilot, non-professional pilot. You want something that's easy to fly, easy to maintain, easy to check out and get ready to fly, maintain. There's a number of things that one needs to maintain, but there's not that many moving parts. So it just stands to reason that it would be easier for a novice person to handle that.
Well, so sorry, I wanted to interrupt here for a second. Talk about this maintenance a little bit.
Sure.
So we know that we have airplane mechanics, right? We have helicopter mechanics. I would imagine that their knowledge would be more than is necessary for these helicopters,
well,
right?
particularly if they're a helicopter A&P mechanic or one trained in helicopters, there are some things that one has to do that do require training and a skill level. For example, the rotor blades, as in any helicopter, have to be what's called tracked, so that they stay in the same plane. One's not riding above the other one, or that sort of a thing. They have to fly, shall we say, in the same track. And there are adjustments on the helicopter, and you use tracking equipment, but you track those blades. That takes a certain amount of skill level, but that's about the most skilled person or process, and that doesn't have to be done every time you fly, maybe not even once a month, maybe only once a year does that have to be done. It depends on how much the helicopter's flown and so forth. But
like an oil change, you'd take it to a mechanic. I would. I can't change my own oil, but for something bigger, yeah. Okay.
Absolutely.
Checking on that, because I figure having that base knowledge of a regular helicopter, I'm sure you can utilize that same knowledge.
Yes.
And move laterally.
Absolutely.
Okay.
Yeah, the tracking process. Well, there are differences on how the blades are adjusted from one type or brand or of helicopter to another, but the result is exactly the same.
Yeah.
Yep.
Awesome.
That's exciting too about the heat going through it. My only experience in a conventional helicopter, ICOSA Media a few years back was filming a commercial for a helicopter manufacturer, and they wanted the Rocky Mountains and the snow-covered tops and everything. And so it was scary having them talk about, I wonder if the ice is like going to be a problem, if the temperature is going to be a problem, and all this sort of stuff, and having the door open and feeling it. It was a little scary, but knowing that the heat from the air going through will keep those blades warm and de-iced, that's got to be great for confidence.
Oh yeah, it's one less thing you have to worry about for certain.
Yeah,
that's awesome. I want to switch gears a little bit on you here. We mentioned in the last segment that we have some investment opportunities, and I know it's a little complicated at this point with this process, just because you are so new and we are working on things. So let's talk about what kind of revenue we're looking for and who should invest.
Well, I don't know that I can really talk about that, but I will say this. We are currently in the capital formation process. We're looking for a number of things because we would like to, bottom line, we would like to manufacture this helicopter somewhere in this area. Colorado certainly. My partner happens to be with a company in San Diego. there's two of us that are the principals in this company at this point in time. He's an engineer, and his resume and everything else is on my website, as is mine. But suffice to say, we're looking for, if you might vision all the resources and kind of think about what it's going to take to do a startup like this, that's what we're looking for. So I just call it that we're in the capital formation process, which includes money, which includes buildings, which includes locations, people, personnel, all kinds of resources that it's going to take to put this helicopter into production. But initially the kit, and as I said earlier, we can have this helicopter kit into production from when we launch. We haven't yet, but from launch date to when we're in production as a kit, we can do that in 12 months. It isn't like, we're going to try and see if this helicopter works or if it flies or whatever. We've flown it, we've done it, we've engineered the rotor head, all of the components on the production helicopter. The engineering is done. Is it pretty? No. But it's a two-place helicopter. It flies very, very well. But right now we're in the capital formation process, and it includes all of those assets that you would think about would have to be there for us to accomplish this. And my contact information, if anyone is interested in learning more or seeing how they might participate, etc., is on our website, Airbat Helicopter, singular, airbathelicopter.com. And I'd be glad to talk with anyone about it. Just getting my cell phone is there. My email address is there. I'd encourage anyone to get in touch with it, because we need a lot of resources to bring this to fruition.
Right, exactly. So you mentioned that Colorado is somewhere you would like to keep this hub.
Yes.
This initial hub. Why, if you don't mind diving in a little more on that for me? Is it the altitude? What's the
No,
the catch?
it really isn't any of that, Alex. It's that I live here. I've lived here since 1983. I've lived here a long time. I love Colorado. I live in Colorado Springs, not Denver, but it could be Colorado Springs, Denver. It could be Fort Collins, or anywhere up and down the Front Range, or parts of it here, parts of it there, whatever. But we're to the stage now where we're ready to start talking to people and start bringing resources together to bear to pull this off.
Right, and so you are looking for manufacturers, correct?
Yeah, well, we're going to manufacture a lot of the parts in-house, but we're looking for people to make sub-assemblies, etc. Yeah. Mm-hmm.
Awesome. So we might be able to help you out with some manufacturing companies. We have a lot of
Cool.
manufacturing partnerships.
We do. I'm
with
sure you
Colorado
do.
Business Roundtable. Yeah.
Yeah,
so
I'm sure you do.
We'll see what we can get there, and I will also make sure they see this video.
Well, I appreciate that very, very much.
Yeah. So, Steve, we have a few more minutes here. Keenan, any other technical questions? You're my technical guy.
Yeah.
Thinking about this.
I'm kind of curious on the walkthrough. So I'm imagining I'm a pilot. What
Okay.
might a morning look like when I want to go take a flight? Maybe I'm traveling to work, maybe surveying some land or a project like that.
Sure.
What's the process look like with the Airbat helicopter versus a conventional one?
Oh my goodness, a big difference between night and day.
Okay, a big difference.
Big difference. Of course, like any aircraft, you're going to want to do a walk around, to make sure that everything is in the right place and so forth.
Mm-hmm.
That pitot tubes and for your instrumentation, those sorts of things are clean, and any storage. Protective devices that have been applied to various things have been removed. Those
The
sorts of
remove
things.
before flight tabs,
check
all those.
the fuel levels and so forth, oil and so forth and so on. But other than that, this gas turbine, the model that we're using was built by Solar. It's a Solar gas turbine engine. They're built in San Diego. but they're very, very easy to start, maintain, and to bring them up to speed, those sorts of things. So other than that, it's just doing the walk around, so to speak, and making sure everything is ready to go, and get in and again do your check off like what you would in any aircraft, and you're ready to start and
You're
lift out.
ready to fly.
Yeah.
Wow.
Yeah, that's so different. There's a lot less computation involved and everything else.
Yeah.
I am so fascinated by this. I would love to invest in one myself eventually. We'll see if I win the lottery. And
Speaking of that, do you know, investing in one of the individual helicopters as opposed to even the company, do you have an idea of what the price range might look like for one of these kits as you're designing them?
We don't have an exact price yet, but it looks like that the price for the kit is going to be just a little bit under $300,000, or about $300,000.
which is, I believe, very reasonable.
Well, for a gas turbine-powered helicopter, yeah, it is. But it's going to be in that range. We don't have all the costs nailed down yet, but it's going to be very close to that.
Awesome. Do you think there will be a decrease or an increase in price as we move towards these battery packs?
I'm expecting an increase.
I would too, just because it'd be new technology.
Right, and I don't believe, at least we don't have plans at this point, to produce the battery-powered helicopter as a kit.
Okay.
We'll go straight to a fully certified vehicle with that model, as well as we'll only produce the 2-place as a kit. The 4 and 6 place will be certified, fully certified, and but they'll be a lot less expensive than conventional. There really isn't. I mean, there are some conventional helicopters that are, you might say, competition, so to speak, and they're in the $800,000-900,000 range, certified, fully assembled, and this probably for the 2 to 4 place will be in that price range or close to that. But there's a lot of engineering work to do to get to the point where we're going to be talking more specifics about that particular aircraft. The 6th place, compared to a conventional gear-driven helicopter, will be a whole lot less than a conventional helicopter. And I really, really believe we've done enough engineering work and costing work that ours will be a whole lot more profitable for us. And I also believe the demand, we really believe the demand for this helicopter of all the levels will approach 1,000 units a year, much more than the conventional market enjoys. That's without military, those sorts of things. That's without that layer, that whole arena there. And I believe there's application there as well.
Wow.
But
yeah. Oh, I would love to see if you can get involved in the military market.
well, when you talk about border patrol, this helicopter is not only all the benefits. There's one other big benefit, and it's quieter. If you hear a helicopter approaching you and then going over and past you, the main part of the noise you hear is the tail rotor.
Oh, really?
Yeah.
And which...
there is no tail rotor.
Real quick with this one, so there's no tail rotor for the air-powered helicopter, but there is kind of a vane, so it does move back to keep it steady. Is that correct?
Yeah, well, you can actually fly it with your feet flat on the floor. You pick you just pick it up into hover, and it will vane in to whatever direction the wind is from. You can then just take off, and you're already lined up in the wind. And it's aerodynamic. So that it always vanes into the relative wind. Now the model that's pictured on our website does have a tail rudder, R-U-D-D-E-R, not rotor, and that gives some directional control because it's hinged on a 45-degree angle, so it catches the downwash.
Oh, cool.
And it will kick the tail around. With the turbine-powered model, we were flying that one with the turbine and a recip. That picture is on our website, but anyway, the new one though, it uses the jet blast from the turbine on a rudder, and that kicks it around very effectively. If you want to fly crosswind or whatever, but it flies very well. Just vanes into the wind.
That is wonderful. Thank you guys so much. This has been a fascinating conversation. I like that word a lot. But yes, for more information, again, that is airbathelicopter.com.
Correct.
Be sure to like and subscribe our YouTube page while you're here. Find out more at airbathelicopter.com and cobrt.com/radio-podcast. Have a wonderful day.